High-tension cable barrier is a system typically installed along highway medians to prevent crossover head-on crashes. It is designed to capture and absorb an errant vehicle and return it to the road. Most vehicles can be driven away after impact with the barrier, although some vehicles may get entangled in the cable and need to be removed. The high-tension cable barrier system consists of steel cables mounted on posts. The cable has a minimum breaking strength of 39,000 pounds. Typically, there are 4 cables on a system. It takes only one cable to effectively capture or redirect a vehicle. The posts can be spaced at varying intervals depending on the desired deflection, and are designed to bend or yield to the ground line when impacted, allowing the cables to remain engaged with the vehicle. Depending on the manufacturer, plastic or steel hardware components are used to keep the cables at a uniform height throughout the system. Each run of cables has a starting and ending terminal. Cable release posts are found at either end of some systems, while one system end terminals are designed not to release, so cable tension is maintained after an impact. Turnbuckles are used to splice 2 cables together. Anchor terminal fittings are used to connect the cables into the end terminal foundation. These systems are highly effective in preventing head-on crossover median crashes, which can lead to serious injuries or even death. High-tension cable barrier is more cost-effective and quicker to repair than traditional guide rail or concrete barriers. Although cable barrier systems vary by manufacturer and design, they generally react in a similar manner during impact, as shown in this crash test video provided by Gibraltar Global. As a first responder, when you come upon a crash scene with a vehicle entangled in the cable, your first thought may be to simply cut the cable to extricate the vehicle, but doing so can be extremely dangerous. Cutting the high-tension cables can cause them to whip around and injure you or others nearby. There are safer options you should learn first. Let's learn about them in order of preference. The first option, considered the safest choice, is to reduce tension on the cable by removing posts as necessary. Remove posts by hand on either side of the crash to further reduce the tension. On certain systems, you only need to remove every other post to reduce tension. If it is necessary to cross over the cables, this may take 100 feet or more before you can lower the cables to the ground, but all posts would need to be removed to do so. If option 1 does not work, option 2 is to cut the turnbuckle. A rotary saw or hydraulic cutter, also known as the jaws of life, can be used to cut the turnbuckle on the affected cable. Make sure there are at least 5 undamaged posts between the crash scene and the turnbuckle. Cut straight through the middle of the turnbuckle, keeping the cable and fitting intact. Please note, cutting the turnbuckle can be dangerous. Personnel should be directed behind the person cutting the turnbuckle or in another shielded position. By cutting just the affected turnbuckle, the remaining cables will still be in service. The third option is to release the tension at the end anchor. If the vehicle impacts the barrier near an anchor or there is no turnbuckle nearby, release the tension at the anchor. Pushing over the end treatment at the anchor will release the tension in the entire system. A vehicle bumper can be used to push over the end treatment. If the crash or something else is blocking access to push the end anchor over, you can use rope or strap to pull it down from the other direction. For systems with non-releasing end terminals, individual cables can be released by removing hardware to relieve tension. Please only release the cables that are entangled, so the other cables can remain effective. Please note, releasing the tension at the end anchor takes the system or cable out of service until a maintenance crew can repair it, making it ineffective in protecting others on the road. The fourth and final option is cutting the cable. This is extremely dangerous and should only be done if all other options fail and injuries require immediate medical care. Personnel cutting the cable should wear proper PPE, including face and eye protection, helmet, appropriate gloves, chainsaw chaps, and steel-toed boots. First, move to an undamaged section of cable. Wrap the cable with duct tape if available and time permits, and use a rotary saw or hydraulic cutter to cut the cable between the duct tape. All personnel should be directly behind the person cutting the cable or in another shielded position. Cables typically retract along the center line of the system when cut in an area of undamaged posts. Let's recap these emergency procedures. Keep in mind that you should always attempt to remove the vehicle at the same angle it entered the high-tension cable barrier. Remove posts to reduce the tension on any entangled cable. Posts can be lifted out of the socket or cut off with a saw. If that doesn't work, cut through the turnbuckle, but only cut the turnbuckle for the entangled rope. The third option is to release the tension on the entire system or individual cable at the end terminal. And if all else fails, cut the cable, but only if injuries require immediate medical care. First responders may need to cross a cable barrier at mid-location. Avoid trying to lower the cable to cross to the other side of the barrier, as it could take 10 to 15 minutes at a minimum. Use an exit or median crossover to avoid interaction with the barrier, or cross the cable where there is a gap in the run. If necessary, to cross over the barrier, remove a post by taking out the locking plate and hairpin, or spacers, clips, or similar retainers, and then pull the post out of the base. Once several posts have been removed, the cable can be lowered to the ground. A piece of plywood can be placed over the lowered cables to allow an emergency vehicle to drive over the wires without risk of entanglement. A final tip: many first responders have success in using a tow truck with a boom when the cable is on the wrong side of the system. The boom can be used to grab the cable and lift it to return the cable to the correct side. This is a much safer option for first responders versus cutting the cable. To learn more about high-tension cable barrier, please visit pa.gov/infrastructure safety or scan this QR code.